Students, this is Mr. Kashi speaking. With this video, we're going through our second day of 10-1. This is going to be our intro to series. My Bitmoji got cut off a little bit there, but hopefully it says series. It'll be I'll try to be making one of those for each one of our lessons here with the different titles. But so just a couple of definitions, and then I'll go through 4 examples here. So what a series is it takes all the numbers in a sequence and then adds them up. So it's the sum of the terms of a sequence. And then obviously we have 2 different types of sequences, finite and infinite. So a finite series would be the sum of a finite sequence. An infinite series would be the sum of an infinite sequence. So for today, we're just going to be doing finite series. In later lessons, we're going to be focusing on different types of sequences, different types of series, and we'll get into infinite series at those times. But our first example is another thing that we need to kind of talk about is this fourth partial sum. So it gives us an equation, and basically what a fourth partial sum means is just add up the first 4 terms. So here we would just go through, find a1, and so this would be -2 to the first plus 3, that would be 1. Find a2, -2 squared plus 3, well, -2 squared, that's a positive 4, plus 3, that would be 7. a3, -2 to the third, that would be a -8, plus 3, that would be -5. a to the fourth, that would be -2 to the fourth, that would be a positive 16, plus 3, that would give us 19. And then all we have to do is we have to add up all of these together. So I just come up with a sum. So this would be 8 and 8 and -5, that would be 3. So this would have a sum of 22. And there's different ways to write your answer. What we're talking about with sum and a series is basically if we were to say, because we have the partial sum of 4, we would say S4 equals 22. The partial sum of this series would be 22. So we'll go through a handful of examples here and something called sigma or summation notation as well. So our second example would be finding the 6th partial sum. Now this is recursive formula here. Okay, so we have a1. They already told us what a1 is. Okay, and we need that in order to do a recursive. And then we're basically just multiplying 0.5 by the one before it. So we have a2 is just 0.5 times 8, which that's going to be 4. a3, that's going to be 0.5 times 4, that's going to be 2. a4, 0.5 times 2 equals 1. a5, 0.5 times 1 equals 0.5. And a6 equals 0.5 times 0.5, which is 0.25. We need to add all of those up. So we add 8 plus 4, that's 12, plus 2, 14, 1, 15. So this would be 15.75. And once again, writing your answer would maybe look something like S6 equals 15.75. That would be the answer to the 6th partial sum of this sequence. Now moving on to sigma notation. This is just kind of a different way of writing a series of writing where kind of a different way of looking at it. Kind of some shorthand here. We always do our I don't want to say first term of the sequence. I'm going to say starting term. So you can start at the first term, or let's say we don't want to start at the first term, we want to start at the 5th term. We could start at that one. And then we'll put last term here, or maybe our ending term is maybe we might end before the sequence actually ends. This a of n, that is the equation that we're going to use. Okay, and that could be explicit or recursive. It doesn't matter. Okay, and then what that means is that we just take where we start and where we end, and we just add them all up. And so that's our process here isn't going to change a whole lot. It's just this summation notation gives us some flexibility on how we write these, where we start, where we end, and how we can use them in different problems. So to find this sum, okay, so we have starting out with our first term. So just like we were doing on our last examples, we have A1 equals 4 times 1 minus 3. That would be 1. A of 2, 4 times 2 minus 3, that would be 5. Then we have 4 times 3 minus 3, that was 9. And hopefully you can see that we're going up by 4, right? And going up by 4, and well, that makes sense because we're multiplying by 4 each time. So really, we could just go A4, A5, come over here and just say, okay, this would be 13, and this would be 17. So we didn't really need to go through all these if we already know the pattern of where it's going to be going. Now we have to add them all up. Here we have 30, 39, let's see, 40, 44, 45. So here we would have, basically what I would write this is I would just go over here and say this equals 45. So we don't really use the S6 here because the S6, the difference between S6 and sigma would be, or sorry, this would be S5, is that S5 means that we're doing the first 5. Here we're not necessarily starting at the first term. We could start at the third term. So that's where sigma notation is a little bit different than the answers that we've been writing before. So here's another one. This seems like a long problem, right? Because we start at term 4, and then we're going all the way up to term 11. But the whole point of this example is to show you that once you get going, you don't have to write all of them down. So if you're to say, okay, we're going to start with A4, and so we have 30 minus 4 times 4. Well, 4 times 4, that's 16. 30 minus 16, that's 14. Then we have A5. 30 minus 4 times 5. Well, 30 minus 20, that would be 10. A to the 6th. 4 times 6. 30 minus 24, that would be 6. So hopefully you can see that we are subtracting 4 each time, which makes sense because we're subtracting 4 times just another 4 each time. And so really we could keep going, but I can just go A7, A8, A9, A10, A11, and I could just come over here and say, okay, well this is going to be 2, then minus 4, that's going to be minus 2, minus 6, minus 10, minus 14, or we shouldn't be saying minus, it should be negative 2, negative 6, negative 10, negative 14. Now, hopefully, you can take a look at this list and say, well, we started at 14 and we have a negative 14. If we're going to be adding all these up, well, those are going to cancel out. The positive 10 and the negative 10 cancel out all the way down till we have nothing left. So this actually, the sum of this ends up being 0. We started with the 4th term, went to the 11th term, and they all canceled each other out by the time we were done with it. So that's something that you see from time to time as well. So hopefully these video examples kind of gave you a good introduction to what series are and just kind of the basics of them. We're going to be diving deeper into sequences and series with a handful of videos to come.